Alright, so this is chapter 18, chemical bonds. And so we're going to start actually making chemical compounds. Alright, so first of all, let's just talk about compounds real quick. We already defined compounds earlier this semester about that they are the same combination, or they're combinations of elements in the same ratio always. So they exist at the same ratio of elements always. So, for example, I like to use water, right? It's always 2 hydrogens and 1 oxygen always. It has that same ratio all the time. That's what a compound is. And so we're going to talk about how to make compounds, basically. So, every compound has what we call a chemical formula. Oops. Helps if you hit pin, sorry. Has a chemical formula. Now, meaning that we have elements and symbols that represent the compound. It shows what elements are in the compound and the exact number of atoms in each compound. So, for example, like this one shows that water H2O shows that it has 2 hydrogens, 1 oxygen. Some other examples down here, we have SiO2, which is silicon dioxide, also known as sand. It shows us that we have two silicons and, one silicon and 2 oxygens. We have laughing gas, which is dinitrogen oxide. It has 2 nitrogens and 1 oxygen. So the chemical formula shows the exact ratio and what elements that compound contains. Now, how to make a compound. First of all, you have to have an understanding that all atoms want to be like the noble gases. They want to be what we call happy. And I have an extra S there, so I'm sorry, you can take that out. Want to be like the noble gases. So they want to be happy, meaning that every element wants to get 8 electrons in their outermost shell. So what will they do? They will gain, lose, or share electrons to be like the noble gases. Because they want to have that 8. They want to have 8 valence electrons. So atoms will make chemical bonds in order to make or be like the noble gases. Now, we've already kind of seen this slide in the previous chapter, where remember when this is what you use to make your electron dot structures. And so just to review, so that we have this in our banks right now, remember that if it's in group, the first column, it's got 1 valence electron. And remember that valence just means outer electron. Meaning that if we had a model and here is the nucleus and we have our rings, the outermost ring would hold 1. Okay. Or if you draw your Lewis dot structure, remember, I think that's even a simplified form, like if you have hydrogen, its outer one would have 1. This group here, 2A, has 2, 3, 4, and you get the picture, all the way out to 8. So this group right here is the most stable. It's happy. Everything except for helium has 8. So they are, and in fact helium, this first column here, they're kind of weird. They like 2 most of the time. So if they had 2, they'd be happy, because they would be like helium. Everything else here likes 8, and they have 8. And everything else in the periodic table wants to get like the purple column over there. They want to be like the noble gases. So one of the ways that they do this is they form ions, and that's the first thing we're going to talk about is ions. Ions are when an element gains or loses electrons. They basically form ions. They do this so that they can become like the noble gases. So, the first possibility is when it actually loses an electron. So, for example, sodium has 1 little valence electron. So, he might lose that in order to become happy. So, he would become a cation, and yes, it's pronounced cation, not cation. Cation, and so it would become a positive ion. Anions gain electrons to become negative ions. For example, Oxygen normally has 6 valence electrons. So what it might do is it might go and gain 2 more. And look now, it has a full 8, a full octet. So it would be happy just gaining those 2. And you have to remember that electrons are like big, heavy boulders. It's easier to take away or gain based on what's the least amount of work. So for sodium, it would be a lot easier to take away 1 than gain 7. Oxygen, it'd be easier to gain 2 than take away 6, because that's the least amount of work. How do you know what makes what, though? What's an easy way to help yourself? Okay, well, here's a periodic table that you could go through, and these are the most common ions that you will know. So I've color-coded those. So lithium, basically your alkali metals, make 1 pluses, meaning that they will lose 1 electron and become a 1 plus. Beryllium down to radium will become a 2 plus. Aluminum is the only one in that column that you actually know the charge of. It's a 3 plus. Nitrogen, phosphorus, and arsenic, 3 minus. Oxygen, sulfur, and selenium, 2 minus. Fluorine, chlorine, bromine, and iodine, 1 minus. So those are the ones, those are what I commonly refer to, as our group A elements. Those are the ones that you know the charges of always, okay? Or I'll refer to them as type 1s. And so that's my short little video about ions.